All right. I hope everybody's doing good, and I know you're enjoying the fact that you're not in school, all right, but you still have to learn. So today what we want to move on to and start a totally new topic, and we're going to talk about integers and the meaning of an integer. Now, first of all, an integer is sometimes referred to as a signed number. And the reason it's called a signed number is because the number has a sign on it. Duh. Okay? And again, it's not a stop sign or a no smoking sign. It's a plus sign or a minus sign. And the plus sign stands for a positive integer, and a minus sign stands for a negative integer. So integers are positive or negative or negative whole amounts. And again, you say, well, what is a positive or negative whole amount? Well, positive integers are the type of numbers that you've dealt with since kindergarten or pre-K, all right? Because a positive integer is a number to the right of 0 on a number line. And again, if you remember, Miss Mouton and Miss Weason most probably had a number line taped to their desk that started at 0 and then had 1, 2, 3, and so on. By the way, you remember from geometry, this arrow here means it goes on forever. And again, this is a positive 1 because it's one place to the right of 0. And this is a positive 2 because it's two places to the right of 0. And of course, this would be a positive 3 because it's three places to the right of 0. All right? And again, all the numbers that you dealt with were positive integers. So now we're going to deal with some called negative integers. And a negative integer is a number to the left of 0 on a number line. And again, those would be like here, going this way. One place to the left would be a negative 1, two places to the left would be a negative 2, and three places to the left would be a negative 3. And again, negative integers are whole amounts to the left of 0. Now, sometimes you might say, why do we have to have negative integers? Because, like when you measure temperature, you have above 0 and below 0. 5 degrees below 0 means that the thermometer went underneath 0 to below. Okay, you could have a deposit or you could have a withdrawal. A deposit is something good you're putting in. A withdrawal is something bad you're taking away. You could have a loss or a gain. A gain would be positive, good, and a loss would be negative, okay, which is the bad one. So again, these are what integers are. Now, we're going to be working with integers, and there's three major things that we're going to use integers to do today and on your IXL topics, okay? The first thing is we're going to talk about something called additive inverse. And additive inverse is very easy to do, okay, if you know the synonym for additive inverse. And you know what a synonym is. It's not the stuff you put on your toast. That's cinnamon. Synonym is a word that means the same as another word. And the synonym for additive inverse is opposite. So, if I wanted the additive inverse of a positive 2, I want what's the opposite of 2 places to the right of 0? And the opposite of 2 places to the right of 0 would be a negative 2. which is 2 places to the left of 0. Or if I wanted the additive inverse of a negative 5, what's the opposite of 5 places to the left of 0? That would be 5 places to the right of 0. And again, you would notice that there's no equal sign in between here because they're not equal to each other, they're exactly opposite each other. So you're saying additive inverse changes to something else. And again, what do you think the additive inverse of 0 would be? If you said 0, that's absolutely correct. So 0 doesn't really have an additive inverse itself because it's already at 0. By the way, if you had to explain to somebody an easy way to get additive inverse, you would most probably just say change the sign. If it's positive, make it negative. If it's negative, make it positive. Because that's the opposite of what it was. All right? And this is very easy to do. Now the next thing is something called absolute value. And the symbol for absolute value would be 2 straight lines on the outside of the number. Just like you put parentheses on the outside of the number, you would put these 2 lines on the outside. And again, these lines mean absolute value. I've had students before who asked me, what do you do with those little thingies on the outside? They're not little thingies on the outside, it's absolute value. And what absolute value is it's the distance a number is away from 0. Now what you need to understand here is that distance is always a positive amount. You can't have a negative distance. You can't run a negative mile. You could run a mile backwards, but it would still be just a mile. If you go from here to Houston, you see a sign that says Houston 236 miles away. If you're going from Houston to here, you don't see a sign that says New Orleans negative 236 miles away, because distance is, always positive. All right, which means since distance can never be negative, therefore absolute value is always positive. Okay, so if I want the absolute value of a -3, I want to know how far away from 0 is a -3, and it's 3 places. If I want the absolute value of a +5, I want to know how far away from 0 +5 is, and it's 5 places. And again, since distance is always positive, your absolute value is always positive. Now, one thing to notice about this, please notice you don't put absolute value signs on your answer. That would be not an answer, that would be another problem. If you said the absolute value of -3 is equal to the absolute value of +3, that's true, but it's not an answer. That would be like saying 2 + 3 = 4 + 1. It's a true statement, but it's not the answer. So when you give the absolute value of a number, please don't put absolute value signs on your answer. All right? The other thing you have to worry about is people get additive inverse and absolute value confused all the time, because they both start with an A and they're both 2 words. But you have to remember additive inverse is opposite, which means you change the sign to a different one. Absolute value is a distance from 0, which is always positive, which means you make your answer positive no matter what. But again, don't mix the 2 up with each other, because that's not true. Sometimes additive inverse and absolute value do the same thing, because the additive inverse of a -5 is a +5, and the absolute value of a -5 would be a +5. But sometimes they're not the same, because the absolute value of a +2 is not a -2, but the additive inverse of a +2 is a -2. So keep that straight when you're working with additive inverse and absolute value. The last thing you need to know here is how to compare integers. And again, to compare integers means to tell greater than, less than, or equal to. Alright? So, if you want to compare integers, there are actually two ways you could do it. One way you could do it is go back to that number line. Again, the old number line with Miss Mouton and Miss Guisson had 1, 2, 3 on forever the arrow. But now we know we have a -1, -2, -3 arrow on forever. And on the number line, you can notice that as you keep going to the right, you keep getting bigger. And that means whenever you compare numbers on the number line, the number furthest to the right is the larger. That's why a +2 is greater than a +1, because a +2 is further to the right. Alright? But now, if I wanted to compare a -2 to a -1, which one is further to the right? Well, a -1 is further to the right than a -2, so a -1 is actually greater than a -2. And you say, well, how can 1 be greater than 2? 1's not greater than 2. -1 is greater than a -2 because one place to the right of 0 is further to the right than 2 places to the right of 0. And again, on a number line, you would always look at which one is further to the right. So if you wanted a -3 or a +1, which is further to the right? -3 or +1? A +1 is, so a +1 is greater than a -3. Sometimes though, if I ask you to compare a -35 to a -42, I don't think you want to draw a number line that goes 42 places to the left of 0. Alright? So here's a neat little way to think about comparing. Think of positive as having and negative as owing. Alright? And if I owe $35 or I owe $42, which would you rather? More money or less money? Unless you're some kind of weirdo, you would always rather have more. So whatever you would rather would be the greater one. So which would you rather, owe $35 or owe $42? I'd rather not owe anything. But if I had to owe something, I think I'd rather owe 35 than 42. And that makes a -35 greater than a -42. I noticed on your IXL, when they were comparing, they actually had a problem that was something like this, comparing the absolute value of a -4 to a +2. And again, you can't compare an absolute value to something. What you have to do before you can compare them is you need to find the value. So what is the absolute value of a -4? A +4, because remember, absolute value is always positive. So I'm really comparing a +4 to a +2. And which would I rather, have $4 or have $2? I'd rather have $4, so that's the larger. So that's the 3 things that they're going to ask you to do on IXL. They're going to ask you to do additive inverse, the opposite. They're going to ask you for absolute value, and they're going to ask you to compare integers. Now, next week, we'll learn how to start working with integers. But this stuff is easy. You should be working on IXL, trying to get to 100% on everything that you do.